Greetings and welcome to the RC Wallet Vacuum channel. Today's video I'm going to be installing the Hall Effect speed sensor into this Taylor 50cc powered Vecta. So anybody hasn't been seen any of the previous videos on this, it's part of a wireless SCADA system I've been developing for these fifth scale big bore engines. And in addition to the RPM sensor, I've got a newly redesigned and built module that goes, a pit box module that will be wirelessly connected back to the transmitter here. So let's dive in and take a quick look at a couple of the additional parts that are going in here. So I did do a previous video on manufacturing this little Hall Effect sensor for the RPM detection. I've since went through and I actually ended up changing it around. I kept the same body of the mount for it, but I switched to a surface mount from the through hole that was in there. I'm going to be modifying a little bit for the next one, but if you can't see it, it's right up underneath there. Just reads the magnet coming up off the flywheel. Unfortunately, I did have to put two holes here for the mount it and tailor it, which I didn't like, and I had to put a slot over here for the wire coming out of there. But other than that, that's the only modification I had to do to it. So I think it just gets fed straight up into this transmitter board mounted up on the front here. The last time I ran this, I had a little plastic antenna up on the front there. It ended up snapping off on me midway. So I switched to just running a simple dipole wire. And being it is a 915 megahertz, but it's like 3.22 inches, I believe, for the antenna length on that. And that'll be a quarter wave resonant. So that should be giving me more than sufficient range. Well over a mile, I'm guessing, a clear line of sight. So being a Hall Effect sensor, they can be noise sensitive. So I do have a decoupling capacitor up inside above the flywheel. That was one of the reasons I wanted the surface mount, so I get a smaller cap in there. And then I also got a real small high frequency cap down on the board itself, the transmitter board down here, to decouple some of the noise. That's actually off the signal. The one up on the inside the motor is in the power supply. So like I've mentioned earlier videos, there's an EGT sensor and a CHT sensor. The EGT sensor has been working really well. The CHT sensor has been a little more problematic up there by the spark plug. Right now it's not really, it doesn't want to hold in its crimp real well, and then I also have a tough time keeping the spark plug in there tight. I'm not sure what's going on with that, but for this today's test, that I may get a CHT readings, I may not. I don't really know until I give it a try. So that about covers the vehicle modifications that have been done. The next thing I did is went through and redid the pit box for the display, and that's over here. I'm not real happy with the box. Definitely will be redone in the future, but it's better than just working with an open breadboard at the pit location. I'm hoping the next addition is going to be put a GPS unit on the Vecta and then send that data wirelessly back to the pit box. Then you'll have the exhaust gas temperature, cylinder head temperature, RPM, and the miles per hour. I don't anticipate any latency issues with the first three parameters coming back, but we'll see if I'm going to have issues with the GPS signals coming back. These radios I don't think they're really much more than 100 kilobaud in transmission rates. On the receiver, that is a touchscreen LCD. I don't have any touch stuff enabled. Eventually I'm going to add in a menu system to go and select different parameters, especially when I get the speed in there. Maybe I'll set some vehicle parameters or something like that. This is the inside of the box. The little LCD display does have a SD card holder built into it. Now I don't have this box set up to have access to the SD card, but eventually when I make a new box, we'll write all the software in there and make that accessible. And that way you can save profiles to the SD card of each run. Assign parameters to each run as far as what vehicle and weather and all that other stuff. And that's where I'll need the menu system and on the touch screen. That was the plan for that. And I do run a little, this is a 3.7 volt, I think it's a 6600 milliamp hour LiPo. And I'm using since it's only 3.7 volt and I need 5 for the circuit in here, I got a charge pump converter in there that just ties right into a USB port to charge the battery. So this is all a very self-contained little box. Just gotta have a USB connection to it, and same thing. I got the little 3.22 inch antenna coming off over here. This is the actual receiver board, processor, and there's the lower radio module. Now back to the RPM sensing. When I was getting ready to set this up in software, it occurred to me I have no idea what kind of RPMs I'm even looking for on these things. So if anybody out there sees this video and knows what RPMs, including the low speed, feel free to put the numbers in a comment. I appreciate that one. But I think I got them. I think my software technique and all the math are correct. Basically what I'm doing is this Hall effect sensor is going to sit and put out a high, which in this case being 5 volts, when it does not see, I believe this is a South Pole magnet. And it'll just sit there and loop. And then once it detects the magnet, it will output a low, pulls output to ground. And then I quick sample a software timer and then just stay in there until it sees a high again. I mean, it passed by there, and I consider it one full cycle. Originally, I was starting off, I was setting a microsecond timer, and that proved to be way too fast. I mean, there's 1,000 microseconds in 1 millisecond, and even at 10,000 RPMs, I think it's like a 166 hertz square wave pulse, or rectangle wave pulse coming off the Hall effect. So obviously microseconds is way too fast. So I switched to the millisecond timer, and it seems to be working pretty good. So I think the numbers I'm seeing up here are going to be accurate, or at least pretty close. So the weather today out there is an absolute royal shitbag, so I'm not going to go out and give it a field test. But I am going to hopefully do a shop test here, and hopefully get all 3 parameters. I'm a little sketchy on the CHT. I'm not sure what's going on with that the last time I tested it, but we'll see what happens today. So when I built this box for the Vecta, I made sure I accommodated for 2 different batteries in here just for this type of projects. I put the larger current one down at the bottom for the radio and the servos and all that stuff. And then the smaller current one I put up on top. And that's just for the receiver, or the transmitter module for the SCADA. That's very low power consumption. Get these things wired in here. Put some kind of covering on it, otherwise it's guaranteed to be on the floor within the first second of this thing firing up. Yeah, one's good enough. Power switch, yep, got some kill switch going on. Showing red. So right now my radio's off, so my transmitter is off, so my fail-safe kill switch thing here defaults to off too. So let me shut everything back off, get the transmitter fired back up, and give it another try. So right now I got the receiver box. I'm probably only 8 feet away from the transmitter module, but like I mentioned earlier, these radios will transmit this signal a couple miles, and I mean it's all just a nice little standalone box. There's no other connections to it. So there's where you charge it with a USB port, and that's it. So what I do find encouraging is I'm actually seeing coherent CHT temperatures today, and that's a positive sign. I gotta go rig up some fans and open some windows and doors so I don't totally asphyxiate myself on VP 110 octane, and then we'll give it a test. Well, as you can see, I was getting numbers off it, and they seem like they might be coherent, but like I said earlier in the video, if you're familiar with the numbers these things run at from idle on up, I mean just approximate, feel free to comment, let me know. It seemed like it was running idle around 3940. That seems high to me, but I don't really know what these things are actually supposed to run, and I just see like 14,000 flash up for a split second. But I almost ended in tragedy because it almost slipped out of my hand off the stand at full rev. That would probably have been kind of an ugly situation. But so I get it up on the ground under the track, which I'm hoping is going to be able to do soon if the weather improves. Then I'd be able to give it a little higher revs and hold it a little bit better and see what happens. So And in the meantime, thanks for watching.